started recording. Now let's get into the program and I'll show this. Right, I'll close this. Now let's get into the fork and vfork, sharing of address space. What exactly you mean by that? Okay, we'll try to look into those things. Fork and vfork, these two things I'll show to you. 1 minute, I'll get into hope. It's 40.2, probably it makes, or 40.1, we'll see it. Study of, oh, not this. Okay, this is something different exercise. Not for you people right now. Okay, okay. Study of fork, and I said here, child get a copy of the parents data space. Now I'm talking about the fork. After this, I'll get into the v fork. Now I said child get a copy of the parents data space. I need to look into that. Heap, stack, everything, a copy it gets it. But when it gets a copy, in a copy, whenever you do the changes, it doesn't get reflected here, right? Parent and child do not share these portions of memory. They get a copy. I told you in my discussion, okay, I get a copy of your textbook. So whatever a marking I do in that copy, it doesn't get reflected in the original book. I need to study this. So for this purpose, what we have done is, I created one global variable here. Then I created one local variable. Right? Please look into that carefully. And local variable I initialized to 113 and global variable I initialized to 10. Right? Then what I'm doing is I'm creating a child process. A new process is created. It gets a new process ID. Right? In the child process, what I'm doing is I'm incrementing these two variables. So what should be the value of this? It should be 11 and 113. Am I right? 11 and 113 for a child process. Am I right, Himarashmi?
Yes, sir.
Now look at the parent. In parent, what is that I'm doing? I'm sleeping for 2, right, seconds, so that a child is executed first. Now child has incremented it and the value of these two variables is 11 and 114, right? And now look at that, both will terminate. Both will use this. Both will print the value of UPK and VAR, right? What is the value it prints? Now look at that. Okay, child will print, right? 11 and 114, it is incremented. But when it is incremented, that one, it should have been reflected in parent also, no? Parent will also print the same thing. And it prints that 10 and 113. What it indicates, right? Child has got a copy of all this variable. Whatever it does a manipulation, it doesn't get reflected in a parent's address space. Address space is the one where all your command line arguments, right? Initialized data, uninitialized data, stack, heap, right? And your machine instruction, they're all stored, right? This study. Now, shall I run this program and look into that? Shall I run this program? Himarashmi?
Yes, sir.
Shall I run this?
Yes, sir.
Okay. Now look into this. Oh, it is already there. Okay, I'm sorry. It is there already. Yeah. See here. What I do is, okay, CC, I'll compile 40-1-fork.c, right? A.out, I run this. Now when I run this, please look into that. Who will run first, whether a parent or a child? No guarantee. It is up to the operating system, okay, what it schedules. It may schedule a child process first or it may schedule parent process first. I don't know. So in parent process, I'm using sleep 2. Even if a parent is called first, through my program, I am forcing it to sleep. Thereby, I ensure that a child process runs first. Is that clear? Why I'm using sleep here? It is my experimentation. Is that clear?
Yes, sir.
Yeah. So Child runs first. What child is doing? It is incrementing UPK and VAR variable, right? And both when they terminate, they come out and print before actual termination. Both will print a UPK variable, VAR variable. The increments done in by the child doesn't get reflected in parents. That's why it's a different address space. They do not share the memory, but they get a copy. Now look at this before the fork. Write message. Now look at that. PID, somebody said that my ID, my roll number is 3123. My parents' roll number is 3122. Now it says that one, my roll number is 3112. That means that I'm a parent of the other one, no? Whatever marking I'm doing, that is a parent of the unmarked output. Am I right? Himarashmi?
Yes, sir.
Right. Okay. Now look at the child. What it has printed? 11 and 114, no? Yes, child has printed 11 and 114. Now look at the parent. It has not, the change by the child, it has not reflected into that. The reason is that one, right? Child, parent and child do not, share the memory. They get the copy. Child get a copy. Your mother has some Rangoli written in a notebook, right? You wanted a Rangoli copy. She will Xerox it and give it to you. And in a Xerox copy, whenever with a red color marking you do that, it doesn't get reflected in your mother's Rangoli copy, print copy on the paper. Am I right? Himarashmi?
Yes, sir.
And that's what is a learning out of this. This is how the fork behave. Okay? Okay or not?
Sir.
Now what I do is in the same program, like without going into the other things, what I do is I'll create a vfork. I'll convert into vfork. That's all. Simple. Now in case of vfork, the procedure is different. vfork, a child process runs within the parent's address space until it executes execl. That means your mother has a Rangoli written in her notebook, and whenever you want it, you are created, you run in the same notebook. Any red marking you do on the Rangoli, it is getting reflected in your mother's notebook only unless you execute execl. Shall we run this and see now?
Yes, sir.
Now what happens, I'll tell you. Child will modify. This is child is nothing but here Himarashmi here. You are going to modify Rangoli here. Two variables are called Rangoli with red color. And when you terminate, when your mother also terminate a program here, before termination, both of you will see a Rangoli sheet. Both will see the same thing because this child is running in the same address space of the parent until it execute execl. That also will see it. Now the output will be same. A child, whatever is modified, it is being updated in the parent also because both will run in the same address space until it execute exec and its variation. The moment it execute exec, right, we'll see in another program. I'll run this. Same thing I do. I'll run. Himarashmi, you can see that one. Here is a Himarashmi. She has modified 11 and 114, right? And her mother also getting reflected that with a change value because child runs in the same address space. What is address space? Command line argument space. Probably look into that. Address space of for program C program is this. Command line argument on the top, which is missing here. Stack, heap, data, text. This is the address space. See, sometimes you have to visualize. Sometimes you have to feel it, right? Sometimes you have to imagine. Got it? When I say that when instructions are executed, what is the meaning of execution? You have to feel it, you have to visualize it. Is this okay? Himarashmi, Manoj.
Sir.
Yes, sir.
So this kind of play, this kind of self-study, this kind of experimentation, you people have to do it.
Sir.
Without doing such experimentation, simply sit in the class or simply copy a program from others and run it, oh, we got it. It is not a learning, right? When I say that one, okay, now what I'll do is I'll change it back to this. When I say something here, right, child get a copy of the parent's data space. What do you mean by this? Parent and child do not share these portions of the memory. How do I experiment it? This is an example. So attending the class is mandatory. Simply if you take a program, okay, then somebody's program and play around, you get some output. Why you got output, you will come to know. But what is the purpose of doing that experimentation? What particular concept you are validating? That is missing if you don't attend a class. Shall we go to V4 and do some other experiments? As a part of continuation of this same doubt. Now look at that, the other variation in your Google class, whatever we have uploaded. One person has sent a message of that. The values are not getting modified. What to do? Look at the program. Look at the program. Right? See here. This is 41-1. vfork creates a new process without copying the address space of the parent to child. But you should not take this in isolation. As child won't reference the address space. Okay, right. The child simply calls exec. The purpose of the vfork is to run another program. The purpose of the vfork is to call exec. Without calling the exec, if at all you create a vfork, it's a nonsense. But until you call exec, what happens is interesting one. While child is running and until it calls either exec or exit, child runs in the address space of the parent. This is a very funny thing. Until you call exec, it runs in the same address space. Are you getting this? Right? So now I will not run exec. Right? But in my program, I have written exec and then I have incremented it. The moment you call exec, right, your program is replaced by the new program called zero test, which I said in my earlier session. So upk plus plus var plus plus will not be executed at all. You have to put a comment, then it will execute. So shall we try this one? Himarashmi, shall we try?
Yes, sir.
That's good. Okay, you have to do experimentation. Right? So look at that. You have to put first, I'll put a comment here. Right? I'm not calling execl. So variables upk plus plus variable this, okay, it runs in the parent's address space and it will increment. I get the same result whatever just now I shown to you. I'll show it now. The 41-1 vfork, right here. CC 41-1 no, it is not one. 41 dash vfork.c. Are you seeing this? Now a dot out. See, there is a change. It is running in the same address space. vfork work like a fork only if you don't call exec. Are you okay here? Are you okay here?
Yes, sir.
Are you okay? Now what I do, is it the purpose of the vfork? No. The purpose of the vfork is to run another program. So what we'll do, we'll make the another program to run. When I run this, immediately the entire address space is filled with a 0 test. This entire program is no longer exist. So the question of incrementing this doesn't arise at all, because that entire code is replaced by 0-test instructions. Are you clear? Are you clear?
Yes, sir.
Entire child memory space is replaced by 0-test. We will check it. But before that, whether 0 test is there or not, we have to create it. Otherwise, we get error. So I will do that. Let's look into that. First, cc -o 0 test. This executable is required for 0 test.c. I'll create the executable. Then I'll run this. 0 test. Yeah, this is my first program. This is my first program. 0 test is available. This program I'll run from another program. What is another program? And that program is this. What is the name of that? 41 vfork. Right? I'll compile cc. Right? 41 vfork.c. Now look at this. I'll run this and see what happens. Right? a.out. This will run another program, child of this. Hey, what is an interesting story here? This is my first program. This is my first program. Who has printed? Child. Child has not incremented a value earlier, because that is no longer exist. The moment exec you call and another program you run, another program will occupy this program. This program no longer exists. What is this program? Child program. But parent will run on its own. It will print its variable. Is that clear? Is that clear?
Yes, sir.
Sir,
Tell me.
sir, I had a doubt.
Tell me.
Sir, in fork, both share a same space and they run simultaneously. So to
No,
differentiate,
wait. Okay, they don't share the memory. In fork, they don't share the memory. They get a copy of that. Okay, please look into that. I will read it for you. 1 minute. I'll read it for you. I'll read it for you. Okay, I said child get a copy of the parent data space. Parent and child do not share these portions of memory. In case of fork, in case of vfork, v4 create a new process, even fork also. v4 create a new process without copying the address space of the parent to the child. But while child is running, until it calls, it runs in the same address space. Together you have to read. It runs in the same address
yes, sir.
space. Assume that your mother is eating in a plate and you are a child of your mother. You also will eat in the same plate. Are you getting it? Until your age become 1 year, you eat in the same plate where your mother is eating. Afterwards, maybe when you started going to school, right, probably your friends will laugh at you. So you have started taking another plate. Are you getting it? Taking another plate is running execl.
Yes, sir. But to differentiate and run the child process first, we call sleep system call in the parent processor in the
Sleep,
fork
sleep, we
program.
call sleep. So child will execute. Child where
Yes, sir. But
child, child where it executes? It executes in the same address space.
yes, sir. But in V fork,
Hmm.
the child runs and parent is being suspended until a child calls exec or exit
Yes, yes,
system calls. So
yes.
then why we are calling this sleep in the parent
Hey,
system?
hey, what is your name? What is your name?
Sunidhi, sir.
Sunidhi. I call the name. Wish to call by name. That's why. Sunidhi, look at that. Right? If I answer to you without calling your name, doesn't sound good. That's what I asked your name. Sunidhi, look into that. This is my experiment where I'm forcing a child to run. But the another property of a child here is that V4 guarantees that child runs first. V4 guarantees that child runs first. So sleep here, okay, is meaningless here. It is a meaningful in case of the fork. Now, who will run first here? In case of V fork, who will run? Whether a child or parent? Always child.
So, but I did this experiment. Like I removed the sleep, sir. But then also the sleep is being the process is being processed first, and then child is
No,
getting
no, no.
processed.
It will not happen in case of V fork. It
If we
will happen.
type something in else, sir,
Ah,
if then also the parent is being executed first, and then the child process is done.
okay, please look. What happens is, okay, this is the property that you need to check. V4 guarantees that child runs first until the child calls exec or exit. When a child calls either of these, parent resumes. This is a property. If it is not happening, then this property is wrong. Let's check that also. Let's check that also. Now what I'm doing is, right, what I do is, right, see here, before V fork that will appear first. Then what I do is I'll put here, okay, I will write, I am child, about to run, about to call another program, right, I'll write it, right, and here instead of sleep I'll say, right, I'll write, I am parent, right? Is that okay? Is that okay? Sunidhi, is that okay?
Yes, sir.
Now how it will execute, I'll tell you, right? It will first print before the V fork. This message will appear first because there are no child at all. Then here a child is created. Assume that successfully it's created. Then what happens is, by description of the principles, whatever we have gone through, child runs first. So this message will appear. And this is printed by a child. Since I am executing another program, right, another program will run. Right? No increment. This will not be executed at all. Right? After exec, moment the exec is called, right, parent will resume. Right? Parent will print, I am a parent. Parent will print this and terminate. Is that okay? Shall we check it? Shall we check it?
Yes, sir.
Look into that. Now you have to compile 41 V. Before that, whatever changes we have done, we have to save it. Otherwise, it will appear in text editor but not saved. CC 41 V4.6. Look at the correct program you are compiling and correct program you are executing. right? A dot out. This is my first. Hey, what has happened? Okay, I'll run this. I'm a child about to call another program. See, before the V fork that you got it, I'm the child about to call the another program. That means child has a case running first, right? The moment exec is called, immediately parent will resume. So parent has displayed, and child, it has been scheduled later. Okay, it's part and it has come here. Is that okay? Sunidhi,
Yes, sir. But exec should be displayed first and then parent
no,
should
no,
come,
no, no,
sir.
no, no, no. Look at that. English statement to be carefully read. What is being said? V4 guarantees that a child runs first. Child is started running. Child started running, it has printed this. The moment exec is called, it will start printing this. It will not wait that it has that it completes everything, right? Zero test will be loaded in the memory. Then it should get its turn. Then it should get executed. Why parent should wait for that? The moment I call execl, okay, parent will resume. It is not being said that one until that is loaded in the memory, until that is executed, that one, right? It will now. The moment you call execl, over. Assume that your brother is Ramesh. Now what you are doing is, okay, you call Ramesh, start the vehicle. Then you start doing your things. Whether he has started the vehicle or not, completed the vehicle or not, you don't wait. You call Sunidhi, your brother, Ramesh, start that vehicle. Then you start your work. Over. So when a parents call execl, immediately it will resume start printing. Whether operating system has executed this or not, it is up to the operating system to schedule. So it has started printing this. And that's what output. Got it? The moment okay, execl is called, parent has started printing, operating system has given a turn. Probably that child process, whatever it is running, it has not fully loaded into memory. It is taking some time and all. There is a waiting period and all. When it is a waiting and all, operating system will not wait. It will schedule other process. Other process happens to be the parent process here. Could be. Are you okay?
Yes, sir.
Mm.
Even like same if we call the sleep,
Mm.
then full child is being printed and processed. After that, the parent get processed, sir. Maybe for that the sleep was given.
Okay, I'll tell you. You are right. So when it comes to the sleep, what happens is, here immediately it has executed. In this case, immediately it has executed, right? If you put a sleep, what happens is, look, a good experiment, Sunidhi. When it comes to print, now even then the execution pattern is same. The moment it call execl, parent will start printing, but unfortunately parent is sleeping. By the time the operating system will schedule zero test, and zero test has printed, then this prints. Whether you put a sleep or not, right? Always the moment execl executed, immediately it start printing here. It immediately start executing this. But because of the sleep, what happens? Parent is not doing anything. It goes back to the child process zero test, and it will execute. Why it should wait? Why operating system should wait for a parent to come out of the sleep? That's called switching, context switch, scheduling. You are right, Sunidhi. Right now I'll execute the same thing. Okay, you will see the different result, but principle what I said is right. After execl, immediately it comes to the parent. It doesn't wait. That principle will remain same. It doesn't wait. It comes to the parent, but parent unfortunately is sleeping, so it goes back to the another one, zero test. and it is not waiting there, it is not sleeping there. It will do its work, and again it will come out, and parent will get a turn. Parent will print, I am a parent. You are right, Sunidhi. Okay, I will show this. Look, an attempt to write this one before we fork. I'm a child process. After this, it comes to the parent. See, look at that. After this, after this, there is a execl. The moment execl is executed, it comes to the parent. But parent is executed. What is executed? It executed sleep. So its turn is over. The operating system will give a chance to the child process. It will print. Then it is the turn of the parent. It will say that I'm a parent. Okay, that's got it. Right? And that is the purpose of the sleep here. Sunidhi, you are right.
Yes, sir.
But the purpose of the sleep here, right, is unlike in a fork. In fork, I'll show you. Here, right, there is no guarantee that which process will run first, whether child or parent. If a parent runs, I don't want it to run, because my logic here to increment this and check whether parent also get reflected or not. So for that purpose, I am putting sleep here. Purpose of sleep here is to enforce that child will run first. And since I have copied same program here, got it, right? It continued. It is okay. It is not part of my logic. Got it. But if you sleep, if you enable that, whether you put a sleep, if you look at the earlier logic in fork, purpose is to run the child first. But here child is running first only. So I don't want this sleep. But if you put a sleep, what happens? That is a different thing. Are you getting this? Sunidhi, am I right?
Yes, sir. I understood the things, sir. Thank you, sir.
Yeah. And this, please remember, Sunidhi, okay, thank you for asking this question. Right? In every course, don't expect all of you, all 70 plus students, all 120 students, don't expect that such a depth things will be driven in all the courses by all teachers. No. In that case, it may not be possible for the completion of syllabus. This is called self-learning. Right? You have to go into the depth of every aspect which it has been introduced in the class. And that is called learning. So Didi, whatever we have done today, this is called learning. Got it? And with that, you will be preparing
Yes, sir.
yourself. With that, you will be preparing yourself for the placement much better. Not by simply doing term work, not by copying from somebody and putting it, or not by showing that one that I have done a term work, I got a S grade. No. By doing this experiment, spending a lot of time, sometimes you may not get the time to prepare for other chapters and all, you may get a B grade also, but your learning is fantastic. And learning that will help for the placement. Anything you learn it completely. Starting from kitchen room to the office room. Is that okay? Is that okay? Himarashmi, Manoj, Sunidhi.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Okay. Now, what next?
Sir, what is the difference between initialized read-write data and just initialized read-only data?
Okay. I have given this particular and is there in the video. Okay, and you can see this. I think instead of this, what is better is to show the other one, memory management. where I've added a command line arguments also. Sorry, I should not open this. And all this video is unedited video. It will appear with all this kind of noise, this kind of delay, this kind of disturbance, everything. And intentionally I'm putting unedited video only, because in a class whatever happens with the noise and all, let it be there when you relook into that. See here, this is the memory layout. This is called address space. The higher address, a command line argument will come and sit here. Let me put marking. Command line argument will sit here. All your stack contents will be here, and it grows like this. What are the stack content? All automatic variables. All automatic variable within a block. The block big is marked by the open flower bracket, close flower bracket. Within that, whatever you do is called block. All variables declared within a block, they are called automatic variables. They are stored in the stack. Heap, it grows like this. What is a heap content? Right? Any dynamic memory allocation you do using malloc and similar kind of things, they are stored in heap. Don't ask me that how does heap works, what is its internal structure. Okay, that you will learn it later. Otherwise, we have to leave the operating system and get into that. Stack and all, you will learn it in data structure soon. Then look at the uninitialized data. Okay, uninitialized data is initialized to 0 by exec. Which one? Right? Look at the global variables. Okay, uninitialized. Okay, this is called initialized read write data. Uninitialized data. Okay, this is initialized to null. Uninitialized data, you don't have value. Whereas this is called initialized. Initialized read write. There is another thing called a comment. Okay, in double quote you write, it is a constant. This is called initialized read only data. Right? Initialized data. Okay, debug equal to 1, initialized data. Uninitialized program is a pointer to character here. That is uninitialized. Right? Are you getting this? Are you getting this? Int I is not initialized, but since it is the automatic variable, it comes and sit in the stack. Okay, if int I equal to 10, if you do it, it is initialized data, but though it is automatic, since it is automatic variable, it comes and sit in the stack. Did I answer your question? Who has asked this question?
Sharadi, sir.
Sharadi, right? Did I answer your question? Given this program, it is there in the our video in PPT also. Got it?
So my question was, what is the difference between initialized read-write data and read-only, initialized read-only data?
What is read-write data? You can read and you can write. What is read-only data? You can read only. You cannot modify it. You cannot modify it. Now look at that. Debug equal to 1. Okay, can I change its value to 20 in the program? Somewhere here, can I change its to value to 20? I can do it. That's why it's called read data, write data. I can change it. I can write into that. I can read. But whereas in my program, right, look at that. I'll change it to yellow color. Ink color, I'll change it. I'll use purple color. Right. Now look into that. This particular thing in double quote, whatever I have written here, this is also a data, but it is a fixed one. When you write in compile time, it is a fixed. But when you run the program, during running when the program is running, can you change this in double quote, whatever you have written message? Can you change? Sharadi, can you change?
No, sir.
That's why it is only read. I can read.
No, sir.
I can only read. I cannot change this one. That's why it's called read only data. In double quote, whatever it is being written is read-only data. Stored, okay, in this, okay, address space. And as a part of initialized data, okay, part, okay, this is stored here. Are you clear?
Yes, sir.
Yeah. Right. Any other questions?
Sir, I have doubt in storage class program, sir.
Okay. Okay, tell me what is the problem that you have? 1 minute. Did I upload a storage class program in the Google class?
Yes, sir.
Yeah. Okay. Tell me. Storage class behavior is this: atomic variable, register variable, static variable, external variable. Okay, their storage, where exactly they are stored: in main memory, in CPU register. What is the default value? Garbage. And the here is, I told you that it is being shifted right, is 0, class 2. Scope, block, and global is shifted. You have to move these things here. Lifetime, till control is in block, persist across the calls as long as program is, okay, running. Okay, now tell me what is the doubt.
Sir, we are printing the address of the register variable, sir. So is the address of the register variable accessible, sir?
No.
Uh, Sir, we are storing the variable in the register, not in the main memory. So we cannot print the address, right, sir?
You are right. 100%. Yeah. But look at that. Your question is that then how does it is printing address? Am I right? Sharadi, am I right?
Sir, I'm getting
Himarashmi or
sir, I'm getting errors, sir. That's why I was asking.
Okay, look at that. Okay, you send a program, I'll check it and see. Register storage class not guaranteed to be stored in CPU register. It may be stored in the main memory sometimes. It is not in your hand. Simple. I'm not getting the error. How do you get it? At the register int I printf address. I'm printing it. I'm doing it, no? Doing it.
So even I got errors, sir.
Okay, we will check it. We'll run it and we'll check it. Right? Right. If, okay, why? Okay, why? If at all it is stored in the register, then you make an attempt to print it. You will not get that. Registers, okay, you will not get it. Right? Check that one. Okay, say it once again. Got it? But very purpose is not to print address. Very purpose is that one, right? It is stored in the register so that you can quickly access that one. Time required to access that one is very, very less. It is very fast. That is the purpose. So all loop index, you can store it in the register. But there is no guarantee that it stores in the register. Okay. Now the meeting is closing and I got another 2 class for the other division. So we'll be, okay, closing this session, and all other remaining doubts, whatever that you have to initiate separately from your end. Did I answer your question, Himarashmi, Sunidhi?
Yes, sir. Sir, I had one more doubt, sir. In this program, sir, the J value is being printed as 0. Like I got it 0. Why not garbage value? I did not understand, sir.
Where, which one? Where is J? Where is J?
Sir, try this. The value of try this we are printing, in that J value is getting printed as 0, sir.
Try this code and observe the output. Okay. So try this you call, and it is okay there, okay, in J. What is a try this? Try this. Now look at that. Okay, int k equal to 35. right? Printing something, returning address of K. Returning address of K, right? I think it is getting terminated. Okay, look at that. Now J equal to try this, right? Now garbage as the stack frame is changed and no longer the K value is available, right? You are, see, here you are using K, which is automatic variable. When the try this function terminates, this K is no longer available. No longer available. Are you getting it? Understood? You are returning the address of K, and whatever K, whatever that memory is there, that value it prints. Garbage in the sense any value. There is no definite fixed value for that. Whatever that memory contains, that one it is. See, when you go to the hotel and store, you open a drawer. Whoever has earlier people left in the drawer, same thing you get it. It could be anything. Okay, that is called garbage. That is called garbage. Garbage in the sense the value is meaningless for you. That is called garbage. It doesn't mean that sometimes you may get to 25, sometimes it's 48, sometimes anything. It is okay. It doesn't have a meaning for you in your program. That's why it's called garbage. That's why it's called garbage. I think we will run this program also and show you right in the next class. We'll run this program and show to you. Don't worry. Right?
Yes, sir. Yes, sir.
But you have to make, that's what I've given a hint also. You have to understand that. Sometimes it is ahead of time. sometimes you have to do experiment and learn. Garbage in sense any value which is meaningless to you. Computationally for your logic it's meaningless. Is that okay?
Yes, sir. So your 0 can also be the garbage value which is given, sir.
Could be.
Okay, sir. And for the register, sir, it is not every time certain that it will store in register itself. It can be stored in the memory also, sir.
Yeah, that's what is being written, no?
Okay, sir.
Okay.
Yes, sir.
Right. I think with this we come to the end of this because it is getting stopped now. I'll stop sharing the screen. Okay, as many as 30 students have participated. What about the other things? Okay, it is understanding that they don't have any doubts as such. Please remember all courses until unless you try, right, you don't understand.